There we go. We are recording. So I will begin. You ready?
Yes, I'm ready.
Thank you all for joining us today to listen to Joe Kuhl talk about the Stillinger Herbarium. This is unfortunately, we had some technical errors and we are re-recording this thanks to Joe's willingness to meet during spring break. Let me introduce myself first and then Joe. So I am Penny Morgan. I am the president of the White Pine chapter. And I was responsible for those technical difficulties, I think. So I apologize. So let me introduce Joe. Dr. Kuhl received his Bachelor's of Science from Iowa State University, went on to a Master's of Science and PhD at the University of Wisconsin in Madison. From there, he did postdoctoral research at the Boyce Thompson Institute for Plant Research. That's at Cornell University and also at Michigan State University. From there, he was employed by the USDA Agriculture Research Service as a research geneticist. He spent 4 years doing that in Palmer, Alaska, until he came in 2009 to join the University of Idaho. He's an associate professor of plant genetics here, and we're really excited that he was recently appointed to be director of the Stillinger Herbarium in fall 2022. This is really important to us in the entire Idaho Native Plant Society and more broadly across the region, because the Stillinger Herbarium is a really important resource, not just to botanists, but to the many of us who are interested in native plants. And so we are really excited to learn a little bit more about the history today and certainly look forward to a really promising future. With that, I'll turn it over to Joe Kuhl.
All right, thank you, Penny. And thank you to the North Idaho chapter, White Pine chapter of the Native Plant Society. Really appreciate this opportunity to come and give this talk. As Penny mentioned, I was hired and came to Moscow in 2009. I have not been working with the Stillinger Herbarium until late last year, late 2022, when I was assigned as director. And I'll say a little bit more about that in a minute. So let me share my slides. Okay. So since I came in 2009 to the University of Idaho, I've been focused on mostly potato genetics. I've done a project with wheat genetics as well, but mostly it's been agriculturally related research. Prior to coming to the University of Idaho, working with the Ag Research Service in Alaska, I did have a project on tufted hairgrass, this Dischimpsia cespitosa, and that really got me intrigued with herbaria and native plants and taxonomy and plant evolution and all that good stuff that goes along with that kind of research. And so when I had this opportunity come up last year to work with the Stillinger and become its director, really it's a chance for me to get back to those activities that I had been part of and would like to become involved in once again. So my talk is kind of split up here into two separate areas. I'm going to begin and give a little bit of history and background on the Stillinger herbaria, and then I'm going to talk to you a little bit about my research on tufted hairgrass, this Dischimpsia cespitosa. So with that, the herbarium at the University of Idaho was established in 1889, pretty close to the same time that the University of Idaho was established. I did see one date of 1892, 3 years after the formation of the University of Idaho. Not sure which date is more correct. At that time, I believe it was just called the University of Idaho Herbarium, and stayed that way until the late 1950s when it was renamed to Stillinger. And I have more to say about the naming of that in a few more slides here. But so the establishment of the herbaria, and then the first herbarium director and collection manager, Lewis F. Henderson. He was also the first botanist associated with the herbarium, and made sizable collections between establishing the herbaria and his tenure at the University of Idaho. The herbarium was originally located in the old administrative building down here in the right corner. Quite a kind of a Gothic building with spires and the peaks over the windows. Anyway, beautiful building. The herbarium was located there, and you can see a couple of the specimens, both collected in 1895 by Clara Ransom. Not sure if she was an employee or volunteer, but the specimens that we have from this time, many of them were established by Clara Ransom. So that is the beginning and early years of the herbarium. There is a marked time point here, March 30th, 1906. That is when the administrative building caught fire and burned to the ground. You can see the picture here in the bottom right. There was not much left of the administrative building after the herbarium. And again, I'm have to apologize, being a little bit new to the herbarium. Some of these numbers that I'm showing here are they're show up in written statements that I have access to, but I haven't been able to confirm the numbers myself. So one number was that in 1906, when the fire struck, there were 85,000 specimens. Offhand, that sounds a little bit high to me, but again, not having any other number to go on, that's what I'm showing on this slide. And as mentioned here, most of the specimens were lost, but not all. I'll show you in a slide or two some of the specimens that survived. In the previous slide, obviously, was showing those specimens from 1895. Those had either survived the fire or were not in the administrative building at the time of the fire. So the first botanist and director, Lewis F. Henderson, remained at the University of Idaho for the next 5 years. I'm sure he wanted to help and rebuild the herbarium collection as best that he could, but I'm sure after that traumatic event, there was probably some frustration with moving forward. And so Lewis F. Henderson left the University of Idaho in 1911 to join Oregon State University, and where he worked with the herbarium at Oregon State for the next several decades, and plays a very significant role in herbaria in the Northwest. throughout this entire time. Kind of the quote here, the grand old man of Northwest botany, just shows how influential Lewis F. Henderson was in the late 1800s and early 1900s. So yeah, here on the right side is a specimen that obviously survived the fire, was present. You can see the soot marks and the burn marks on the leaf here, Calypso borealis. And yeah, so there were specimens that survived, but just not very many. And at some point, I would like to go back and actually figure out how many specimens we have from pre-1906, just to get a better handle on the history of the collection and what made it through. So between 1906 and 1972, there was a significant effort to rebuild virtually from scratch. And as you can see, by 1972, there was in the realm of about 70,000 specimens. So some of the collectors, William Haber and J.H. Christ, played significant roles in trying to rebuild the Stillinger. And you can see Cecil Ryan, 1920 here, Henry Rust, 1916, some of the early collection soon after Henderson left, trying to rebuild the collection. And you know, it's a shame. I just think back and think of all those early specimens that would have been fantastic documentation, what was in Idaho at the time and where it was located, and that was just lost, you know, with no digital backups and other records to go back to. We'll never really know what was there. But you know, moving forward, 70,000 was a great movement in the right direction. So 1972 to 1996, 24 years, Doug M. Henderson was the director. And during this time, the herbarium really started to reshape itself as the herbarium for Idaho. And Doug Henderson doubled down on collecting and expanding the collection, pretty close to doubling it over these years, maybe not quite. Also a very strong advocate to hire undergraduates to work, volunteers, support the local community. So very prominent person, and another Henderson contributing to the Stillinger collection. I would point out that I have some specimens here, and all these dates are prior to 1972. I just haven't had the time to pull out specimens from the time point of 72 to 96. And so this is just from earlier time points. So kind of to give you the current update, the Stillinger herbarium currently has approximately 180,000 vascular plants, approximately 20,000 specimens from bryophytes and lichen. The fungal collection is approximately 15,000 specimens. And at one point in the last few years, the Stillinger could be classified as the 7th largest herbaria out of 65 in the Pacific Northwest. And apparently that would plug it in at 15%, in the top 15% of herbaria worldwide. So The Stillinger is still a very prominent herbarium in the Northwest and in the world. And I'd like to see that legacy continues, and we can build and expand upon that from where we are at currently. And so, yeah, I just have another specimen by Claire Ransom here on 1897, a Baltimore Rhiza. And yeah, I think that even though the numbers here may not be exactly right, I think that the collection will continue to expand under my direction. So I think I've updated this slide when I was actually giving the talk. And so early 2006, the vascular plant collection was moved to the basement of the College of Natural Resources. The non-vascular plants, the fungi, lichens, mosses, I believe were put into storage in the early 2000s. Those did not tag along with vascular plants. And I'm not really giving the history prior to that, since it's a little unclear to me, and I don't have accurate locations and years. Sometime in the mid 2010s or so, the collection, the vascular plants moved out of CNR to the Life Science Building. And I believe that's where the fungal mosses and lichens were in storage at the time in the Life Science Building. So the vascular plants kind of rejoined them in a sense, albeit not necessarily in storage. And then the most recent move, this date is more solid in 2020, 2021. The entire collection, the vascular and non-vascular plants, were relocated to the Mines Building. So this is a image of the Mines Building on campus in Moscow. I believe it was opened in 1971, and the herbaria is located on the first floor. You see these windows in front here. The herbaria is housed in the kind of middle three sections of windows that you're viewing here. That's rooms 116 and 117. And if you or the public were to enter the door here where you see people going up the stairs, you would go through the double doors and take the first left, and you would walk right into the herbarium area. And so here we have stacks that are compressible. That is, they're on wheels and can be pressed together when the shelves do not need to be accessed. They'll roll apart when somebody needs to go in and get access to a particular specimen. The vascular plants are all categorized according to their family based on the angiosperm phylogeny that is put out on an annual basis. Having said that, there are specimens that need to be reorganized based on new classifications over the last few years, but we'll work on that as time permits. And so the location is quite nice. The vascular plants are all in one room, whereas the non-vascular plants are in a second room. The second room with the non-vascular plants also has a work area to prepare specimens and mount specimens to herbarium sheets and allow them to be prepared for storage in the collection. I would say that one deficiency with the new location is at the moment, I have not established classroom space or access to a room where lectures could be given, and students would have an area that they could work with the specimens. And that's something that I will be working on over the next few years, is to try to improve resources in the immediate vicinity of the herbarium, so that students and public or agency individuals can have an area to work, and some quiet space to study specimens that they're interested in. So a slight transition in the talk here. I'm going to talk a little bit about Charles Ray, or C.R. Stillinger. And you can see his years here, 1889 through 1972. And born in Grants Pass, Oregon, and then just 3 years later moved to Moscow, Idaho. So that immediately put him in the vicinity of the university. And in fact, reading some news articles published in the middle of the 20th century, they mentioned that he delivered milk to the University of Idaho's first president, Franklin Galt, and attended prep school at the University of Idaho, 1903 through 1909. And again, I had no clue that there was even a prep school at the University of Idaho at the time. That put him on campus right at the time of the fire in 1906. And again, this is just me reading commentaries about C.R. Stillinger, but it mentioned that he helped clean up the old administrative building in the days after the fire had occurred. And I have to wonder if possibly he handled some of the specimens, saved some of the specimens from the rubble, and moved them to a safe holding place after the administrative building had burned down. So after prep school, C.R. Stillinger entered into his undergraduate studies, 1910 to 1913, Bachelor's of Arts. I have to imagine that that's probably a general arts degree. I didn't see any specific major listed beyond the BA. And then later on, Stillinger returned to the University of Idaho to work on his master's degree in 1915. I believe that was with a forestry major. So after that graduate degree, C.R. Stillinger served in World War I, 1917 to 1919. I believe he was an officer working with the French artillery at the time. And then after 2 years, returned to the U.S. and promptly married Nettie May Bauer. Nettie May, his wife, particularly his wife's name, shows up in the Stillinger Herbarium. I'll mention again in a minute. So soon after getting married, 2 sons were born, Richard in 1920 and Robert in 1921. And again, I believe this is all happening in Moscow, Idaho, or nearby. 1919, C.R. Stillinger returned to the University of Idaho and studied forestry, and then practiced forestry for the next 30 years. And I do know that those 30 years he was moving around the Pacific Northwest and the West, and around the country. He was primarily studying blister rust and was associated with quarantine work for the forest industry. He then retired in 1949 and then settled in Moscow on a more permanent basis. He after his retirement, he was in part managing real estate in Moscow, some properties that his parents and he had acquired over the years. So the Stillinger Endowment was first established in 1957. There was an initial $8,500 that was endowed to Gamma Phi Beta sorority. And looking at the documentation, additional money was given at that time or soon thereafter. So when his wife passed away in 1967, C.R. Stillinger decided to make a more substantial contribution to the endowment. And so there was this $560,000 donation that was made. And this was part in cash, and then there was additional money in real estate. So this is a sizable contributions for the late 1960s and has accumulated interest since then. Now, I will say that the endowment is very detailed wording to it, and in part, some of the money was even set up as an endowment to be returned back to Stillinger's children under various circumstances. But that has all been resolved, and the endowment now lies entirely with the University of Idaho. Some of the real estate was sold off at the time of the donation or soon thereafter in '68, and then in later years. But I believe there's a little bit of the real estate still exists within the university's management. A little bit hard to keep track of all of that. So I also wanted to point out here that Stillinger donated his journals and 6,000 labeled plant specimens at the time. I believe this was in 1968 or thereabouts. So he was really establishing his interest in the herbarium and his collecting that he had done over the years. He passed away, as I mentioned earlier, in 1972. And then just to give you a point of reference, in 1989, endowment was at about 1.1 million. I don't have an accurate number to give you where it is today. I can say that it's distributing annually about $120,000-$130,000 of interest each year, variable depending on the market returns. So the picture here, I have a quote here, and again, this is just to give you a little bit of perspective on who C.R. Stillinger was and where this endowment was coming from. The quote reads, "The seed may have been planted in 1910. That was the year my wife received a $150 scholarship upon graduation from Boise High School to attend the University of Idaho. It helped make her education possible. We planned the trust to do the same for others." So this is a quote from 1968, shortly after his wife's passing. And it goes to show that they really valued the education at the University of Idaho, and they valued the help that even a small scholarship would be able to provide. And so the endowment goes in part to students and in part to other herbarium uses. And so that's what this next slide shows here, the annual distributions. Take a quick look at the non-herbarium funds first. So the percentage here represents the percent of the total distribution on a yearly basis. So 20% goes to a Stillinger Forest Science Fellowship, 8% to a history scholarship, and then 12% to a political science scholarship. And I would mention that the history and the political science scholarships were more kind of geared towards his remembering and recognizing his wife. In fact, one of these, or both of them, had been called the Nettie May scholarship at one time. They've kind of been split out to history and political science. Both are to be given to women in respective areas. So this is going to accommodate about 40% of the annual distributed funds. The remaining 60% of distributed funds goes to the herbarium in different ways. And so 6% to the library, 12% to purchasing herbarium specimens. So I would just point out that back in the 50s and 60s, it was not unusual for herbaria to purchase specimens as opposed to going out and collecting and having those collections donated. And so a chunk of this money is now spent towards collecting and then mounting specimens. There's a fellowship in research that would go to a graduate student conducting research associated with the herbarium at 21%. And then the last 21% goes to specifically to proposals, annual proposals to collect and donate the collected specimens to the Stillinger. And so that's kind of the breakdown here. As I mentioned, undergraduate workers could be paid off of the herbarium specimens component, and undergraduate and graduate students can compete for the expedition funds. Faculty at the university can also compete for the expedition funds. And so, as I mentioned earlier, the endowment is fairly detailed. That as it was set up in 1957 has been amended since then. But I kind of gravitate back to that initial written endowment to get a viewpoint of where Stillinger was coming from and what he was interested in. So on the very first page of that 1957 document, Stillinger wrote that the Stillinger Herbarium, as it became known as in 1957, was there to help encourage the establishment and maintenance in accordance with standard procedures and practices of a university botanical and mycological herbarium. And so he obviously saw that the university had a significant role to play in terms of providing space and potentially salary to maintain the collection. However, the herbarium funds are there to provide expansion and improvement of the collection beyond what the university can do on its own. And so this is a significant help to the collection, but I would point out by no means does this provide all of the funds necessary to keep the herbarium moving forward. And one significant area that I do want to point out is that these funds, none of these funds cover the salary for the collection manager. That is the person who does the day-to-day maintenance, week-to-week communications and distributions to other herbaria, and just keeping the doors open and the public directed in the right direction. That collection manager position is beyond the scope of the distributed funds, and historically had been covered by three colleges: College of Science, College of Natural Resources, and College of Ag and Life Sciences. And when the prior director and collection manager left the University of Idaho in 2021, about 2 years ago. No movement was made to replace the collection manager at that time. And in fact, that was in part because there was no money to fund the collection manager. The College of Science and the College of Natural Resources decided that they would not continue to contribute money for the salary. And therefore, that's kind of on hold. And when I took over as the director in the fall of 22, I have temporary funding for the collection manager. So I will be advertising and distributing that position description in the near future, let's say spring of 2023. But that is a 3-year funding source. And part of my job is over the next 3 years is to establish a stable funding source for the collection manager. All right, so some of the other things that I'm working on, in addition to hiring a new collection manager, just to keep the undergraduates coming in and helping out, giving them a chance to see botany close up, to identify plants, to handle plants, to mount plants. There's a large backload of specimens that have been donated but not mounted. And the specimens, after being mounted, need to be digitized and added to the data set. So there's a lot of work that we have for undergraduates as well as volunteers. If people are interested, they can also come in and help with this ongoing work. Also want to keep the research going. And there is a graduate student that is finishing up now with the former director that is working on specimens in the collection. And I will replace him when he is finished. But there's still specimens that are boxed up and other material that's boxed up from the move to the mines building. And so it's a process of figuring out what's there, what's not there, and what do we want to do with it, whether it's put it on display or leave it in boxes. In the process of working on databasing the mycological collection and process old materials that are still in the box. But one of the areas here, this last bullet, increase outreach to local, state, and regional groups, that is directly tied to hiring a new collection manager and also activities by myself as the director. I really think that over the last 2 years, the herbarium's been pretty quiet without a director and a collection manager. And I just want to raise the visibility and the outreach of the collection to those in the local area. And that would include local, state, and federal agencies that work with the herbaria for completing their jobs. And in fact, I included as part of the new collection manager position description a component, forgive me for not remembering exactly, 15-20% is targeted directly to outreach. So outreach is an important component to the herbarium as I move forward with it. So with that, I'm going to pivot, and the second part of my talk, this will go a bit quickly. Morphological molecular study of Deschamtia cespitosa complex in the Arctic area of North America. So the picture here, this is just a phenomenal kind of a sandy area on the Turnagain arm of the Cook Inlet. So this is a tidal flooded region with, excuse me, tidal flooded area with marine water, and it is almost 100% Dischimpsia cespitosa. And in fact, I know the Plant Material Center there in Alaska had come down to the sandbar and harvested seed from Dischimpsia for revegetation projects. It was almost a pure stand, and as far as I know, it's still there. I haven't visited for the last few years, but just almost solid Dischimpsia. And so I established or started working on this project when I worked for the USDA Ag Research Service in Alaska between 2005 and 2009, working with a colleague of mine, Jorge Chiapella, from Cordoba, Argentina. This is another view of that sandy area, and this is Dischimpsia. You can see we kind of have a shorter plant and a taller plant. It kind of varies or segregates among the population here. And, you know, it might look like mostly tall plants in the back, but that's just what is showing up in the picture. Dischimpsia likes kind of disturbed areas. This would definitely be a disturbed area. There's a creek behind the photographer here going into the Turnagain Arm. And it also does quite well with salty water inundation of its roots. And so it's a fairly hardy plant, although once other plant species start to come into the area, it seems like Dischimpsia gets pushed out fairly quickly. It's not very competitive with other plants, but it is very competitive in newly disturbed areas. So what would establish or what initiated this research project? And in part it was just the fact that Arctic grasses are very difficult to work with. And I think when I say difficult, the classification of Arctic grasses is challenging. They tend to have multiple or high ploidy levels. That is anything above a 2 chromosome sets. They tend to have a lot of morphological variation. I showed you in those previous slides a short plant and a tall plant. But in most likelihood, those were the same species. They have a rather expansive geographic region that they cover, and just conflicting taxonomy. Different botanists at different times give different species or classifications to the plants that they're looking at. And so highly variable species, Festuca and Arcticrostis are just a couple of examples here of challenging species and taxonomy. So a little bit about tufted hairgrass, Dischimpsia cespitosa. It's a completely circumpolar distribution that is throughout Siberia and Europe, Greenland, Arctic Canada, and Alaska. So all the way around to the Kamchatka Peninsula over in the eastern Asia. It's in North and South hemispheres. I would point out that Dischimpsia cespitosa is one of 3 angiosperms originally native to Antarctica. So going down to the Antarctic continent, you know, prior to all the Arctic stations and explorations, there were only 3 flowering plants there, and Dischimpsia cespitosa was one of them. It, like other Arctic plants, has a high degree of morphological variation, both ecotype variation and phenotypic plasticity contributing to that variation. very typical of Arctic grasses in general. So just one quick slide. I don't want to go through this in too much detail, but Eric Holtain really set the baseline for this study in terms of classifying and naming Dischimpsia species and subspecies. He wrote the Flora of Kamchatka Peninsula in 27, and then later on in the 30s and 40s, worked on flora of the Aleutian Islands in Alaska. And so he established several species of Dischimpsia, Beringensis, Flexosa, and Cespitosa varieties, Cespitosa, Glauca, and Orientalis. So we kind of go back and use Eric Holtain as the baseline, and then add in additional taxonomic nomenclature that occurred after his work was completed. So this is a little bit of the history after Eric Holtain. Again, I don't want to spend a lot of time on it, but I'll go to the most recent. So in 2007, a new edition of the Flora North America was released, and the section on Dischimpsia was written by Mary Parkworth and identified 7 or 8 taxa. And so with the Dischimpsia species, she identified subspecies Cespitosa, subspecies Beringensis, and this Holcephoros. There were also species identification of Alpina, Xanthoides, elongata, McKinseyiana, Sukashui, and Flexuosa. So there were a number of other species identified in addition to Cespitosa. So here's some examples of the different subspecies as we worked with them. Here's subspecies Cespitosa, brevifolia, and alpina. And you can see there, it's hard to tell, obviously, from the slide, exact flower formations and variations there, but certainly striking differences in the height of the plant. A couple more subspecies shown here, and again, variation in plant height, and a little variation here in terms of the number of stems and tillers coming off of the basal plant. So the region that this research really focused on was fairly significant. We wanted to start in Iceland, in Greenland, Iceland kind of being on the edge, but primarily Greenland, all across Arctic Canada, all of Alaska and the Aleutian Islands, and a few specimens from the Kamchatka Peninsula. The goal was to study both the morphological variation of specimens as well as genetic characteristics. And again, we were primarily focused on Dischimpsia cespitosa and then related subspecies identification. And so it was an open question, how many subspecies were directly related to cespitosa, and were those truly subspecies, or could they be identified as completely different species? So the work was conducted on herbarium specimens from a wide range of different institutes, the University of Alaska, Museum of the North, Canadian Museum of Nature. There was a small herbaria in Palmer, Alaska. There was Smithsonian Institute, the University of Copenhagen, and then a few specimens from the Museum of History in Sweden. And so these Dischimpsia cespitosa specimens were requested from all of these institutes and brought together. A total of 201 specimens were included in the evaluation, the proper evaluation, 100 from Canada, 67 from Alaska, 19 from the Palmer area, and then 15 from Copenhagen. And then 7 specimens were used as outgroups, and I think I have those listed in the next slide. The breakdown of the specimens is as identified on the specimen sheet. You can see here that a wide range of subspecies related to Dischimpsia cespitosa were included. And the question is, should these continue as subspecies or be reclassified as a separate species altogether? The outgroup, we had 7 species here of closely related genera. These are the locations where the specimens were all collected. I guess I was misremembering. We did not have any specimens from Iceland. We did have a couple specimens from the UK. And then you can see pretty good distribution across Arctic Canada. It was tough getting this Labrador area down here covered. And then very good coverage throughout Alaska and a scattering over the Kamchatka Peninsula in what is currently eastern Russia, and throughout the Aleutian Islands. So very, very good geographic coverage for this species. The data consisted of 55 different morphological characterizations. And for those people who study grasses, they'll quickly recognize that there's a lot of very detailed measurements that need to be made here. Many of these measurements need to be done under a dissecting scope and using a micrometer to get exact lengths. And this is work that was done by my colleague, Jorge Chiapella. I will take no credit for this part of the data. This was all Jorge, and I believe he spent 2 or 3 weeks, pretty constant, 10, 12 hours a day, 7 days a week, collecting these measurements from the 200 specimens included in this study. The genetic analysis included DNA from the chloroplasts, as well as some nuclear DNA. You can see about equal number of nucleotides from each were included as part of the analysis. So analysis of the morphological characteristics alone allowed us to plot each specimen on this principal component analysis. I'm not going to go into the statistics, but you can follow the red lines that identify 4 different groups here. And you can see that the blue group definitely separates out as clearly different class, and that is subspecies alpina. The remaining 3 groups, the yellow, the red, and the green, yellow and green groups separate nicely, Barringensis and brevifolia. However, when you include subspecies cespitosa, the red, it covers a large part of both the yellow and green groups. And so it shows that there is a great deal morphological overlap, particularly when including this subspecies cespitosa. And it tells us that there is more going on than morphology alone will reveal. Although Barringensis and brevifolia subspecies seem to be well defined and seem to group together nicely with the distribution of subspecies. This is just a different way of viewing the data in the previous slide. This multi-dimensional scaling. Again, the subspecies alpina separates out in this B group, and the Cespitosa, Berringensis, and brevifolia are all clustered together in the A group. Sequence data, I don't want to spend any time on this slide. We collected a fair amount of information from the chloroplasts in the nuclear. And when that was analyzed, here, again, more statistical maneuvering with the sequence data, that the HAP are the identifiers for the specimens in our analysis. And you can see that these are, it kind of appears like teeth on a comb, very short, very uniform teeth, very little branching occurring. There is very little genetic variation identified among all those specimens. In fact, we didn't even see subspecies alpina really separating out among all of the specimens involved here. And the outgroup, these are closely related genera, for the most part pulled out. We do have this 41, specimen 41 and 42 that grouped among the outgroups, indicating probably misidentification on the herbarium specimen. And again, this is just a different way of looking at the data presented in the previous slide. And so what were we able to conclude? Molecular basis, the genetics suggests that all of these subspecies are closely related, meaning there's probably a single species here, Trichempsia cespitosa, with subspecies groups. There was really no indication that any of these subspecies should be split out into full-fledged species identification. Morphological analysis, pretty good separation, very good separation for alpina and the brevicalia and Berringensis also separated out. This was using all 55 of the morphological variation characters that we collected. Again, the subspecies Cespitosa had a great deal of overlap with the other subspecies. And then when we included morphological and molecular analysis, it confirmed that the morphological separation was accurate. It just didn't provide any additional resolution on the subspecies. So we're confident in calling 3 of the subspecies, alpina, Berringensis, and brevifolia. The other subspecies were not sufficiently grouped together to call them a single subspecies, and therefore would be lumped under this kind of umbrella of the subspecies Cespitosa. So again, this is just showing the 3 subspecies that we were confident in identifying, alpina, Berringensis, and brevifolia. Any of the other names that were used, again, could be pushed into that Cespitosa umbrella. So this is my colleague, Jorge Chiapella, deserves the bulk of the recognition for this research. Fantastic individual. I really look forward to getting back and working with him. A colleague of his, Guillermo Amico, helped with some of the statistical analysis. Veronica DeBoer, Margaret Dibble, and September Martin all helped with the processing of the genetic information and some of the initial analysis of the morphology. So with that, I just want to conclude this talk, and I believe, Penny, you have a few questions for me.
I do. Thank you so much, Joe. That was really fascinating. Both I continue to be impressed by the Stillinger Herbarium, and I'm really glad you've stepped into the leadership role, and thanks for the DeSamsha example. I wanted to say that we had more than 35 people join us for the Zoom when you did it in person. This again is a remake because of technical difficulties we had. And people had multiple questions. So that's where I'm drawing my questions from, is the things that came up both with people who were on Zoom and others. So probably the question for a lot of people had questions about the status of the collection manager position.
So yes, so things have moved forward. And last week I was told that the Human Resource Department at the university had the position. All the documentation was submitted, and I'm waiting to hear back this week if it will get posted and when. And it could be posted as soon as next week. Which means that I will be sending everybody viewing this and anybody I can get a hold of the position description and the posting. So I think very, very soon the position should be coming out. And it just took a very long time to put all the parts together and getting all the necessary posting documents.
Okay. And somebody else asked how you expect to attract really great applicants. That will make a huge difference for the herbarium.
Oh, absolutely. It's a large shoes to fill. The last collection manager, Ben Legler, well respected and recognized in the local and statewide and even nationally. He did phenomenal things while he was here. I would hope that we could get somebody approaching his level of expertise. I think that my strategy really is to advertise far and wide throughout the Northwest and throughout Idaho, of course, but nationally and potentially internationally. And there are a lot of botanists that get trained every year wanting to work in botany areas, and sometimes it's difficult to find jobs, particularly as associated with academia. And so hopefully by advertising widely, we can get some really nice applicants applying. Time will tell, but I have high hopes. I really think that we will have a lot of high quality candidates applying for this position. I think it is a fantastic opportunity, and I think people will recognize that, and hopefully I can convince them that that as director, I will give them the opportunity to pursue their interests within the context of the Stillinger Herbarium.
Well, I'm excited to see that you included a lot of outreach and extension efforts. Will you be involved in as well as the collection manager?
Yes, no, I fully believe that short-term wise, hands down, yes. I want to get out there and really experience the efforts that we're going to make to get this information out and distribute it to the stakeholders. And so I will be doing some of the work myself, but certainly aiding the collection manager with these outreach efforts in the next few years. I think I need to learn who the stakeholders are and what they're interested in. And the way to do that is to participate in these outreach efforts.
Okay. Pam Brunsfeld mentioned at the presentation that one of the things that the Stillinger Herbarium has helped a lot of people with plant identification. Lots of people came from across the state and beyond who had worked in Idaho, agency people, graduate students, faculty, and I think that will be continue to be really important. What can we do to be helpful?
Yes. So yeah, I guess as I was giving this talk and things were coming to mind, particularly when I showed the picture of the mines building and where their herbarium was on the first floor, and I I remember that many people in the White Pines chapter have not been to the new location in the Mines building. So please come by and visit. We would love to have you stop by. I believe my email is available or can be made available. Shoot me an email and I'll be sure to get you into the herbarium. Currently, the herbarium is open to the general public Tuesdays and Wednesdays, but I can let you in any day of the week. I'll make the time to get you into it. So it's just a matter of shooting me an email and I can get you in fairly short notice.
Okay, let's just say it. J. Kuhl at uidaho.edu. So it's JKUHL at uidaho.edu. So to communicate directly with Joe, and he's been very responsive to me. So there was one question about Dishampsia, and it was really a question about do you know anything about the root systems and how interconnected? Does that help make them especially adapted to the disturbed environments?
You know, that's a great question, and I think the root systems do need to be studied in more detail. It's curious when you look at the global distribution, you know, all over the world, where does Dishampsia cespitosa show up in? And it's certainly north and south polar regions. It does tend to occur in high elevations, mountaintop areas, and along stream beds, roadsides, anything that is frequently disrupted or the native plants are removed. You have bare soil. You'll briefly find cespitosa coming in. It even showed up along the oil pipeline that was put in Alaska between the North Slope, the Arctic Ocean, and Valdez, Alaska, where the port was. But so anywhere disturbed, how the roots are so attuned to taking advantage of this niche, I don't know. The plant is fairly tolerant to low water. It's tolerant to high salt, as you saw from that sandbar. It's a very hardy plant. It just doesn't compete with other plants very well. And in my mind, that makes it a perfect revegetation plant. If you're going to come in and try to stabilize a disturbed area, put Dishampsia cespitosa in there, and the native plants will displace it once the area stabilizes.
Okay. Well, let's stop there. Thank you so very much, Dr. Joe Kuhl from the University of Idaho. Thanks for telling us about the Stillinger Herbarium, and we're really excited for the future. So thank you.
Penny, again, thank you, and to the White Pine chapter. Really appreciate this invitation, this opportunity to talk before the group and Zoom and to make this recording. So thank you so much.
Okay, and thanks for doing it again.
All right.
I'm going to stop the recording now.